Hello and welcome to this session on identity graphs in Amazon Neptune. My name is Ken Phillips and I'm a specialist solutions architect working in the Amazon Neptune team for Amazon Web Services. So what are the topics we'll be covering today? Well, we'll start off by introducing the concept of identity graphs, why you'd look to use graph to model identity and entity resolution, as well as describing some of the most common use cases for identity graphs. Next, we'll dive straight into a demonstration of how you can use a graph database like Amazon Neptune to capture identities and their corresponding information in order to better understand how real-world entities are actually connected or related to one another. Following the demo, I'll be sharing with you links to the demo itself, along with covering ways as to how you can actually get started in building your identity graph on Amazon Neptune. And then finally, I'll finish off by suggesting some options for getting in touch with the Neptune Specialist SA team if you need help. So let's start by first understanding what an identity graph actually is. So initially we need to actually work backwards from the problem. So today, companies collect data from billions of devices, and these are relationships, these are events that actually signal intents to purchase, for example. So oftentimes this data lives in different silos, even though it could be information actually representing the same person. For example, you might have someone that is interacting with a company through many different channels like their retail website, Instagram, a mobile app, and also brick and mortar stores. They might also be interacting through different devices like their telephone, tablet, or indeed laptop. And also they might be logged into their shopper's account on some shopping trips and other browsing events where they're actually logged out. Now, the user is generating a lot of different pieces of data, but in the end, it all ties back to them. Now, we can do a lot with that data, but the challenges we see with working with it are things like a given user might browse a retail platform across many different channels, like a mobile app or website. How do you know if a given anonymous user is actually a known user? They might also visit these platforms, use different devices. Maybe they have a phone, a tablet, a laptop. And sometimes they might be browsing the platform while logged in, or sometimes anonymously. But in the end, all of that browsing activity, even though it's coming from different channels, is tied back to a single unique person. A second challenge is how do we actually generate recommendations or targeted advertising when people interact with our platform anonymously? In order to generate a personalized recommendation, you need some knowledge of who your audience is. So what we really need to address these problems is something that would give a complete view of a customer that interacts with our business across multiple channels so that we can provide better product recommendations and a more tailored shopping experience. Enter the identity graph. Now, this is a tool for stitching together all these different identifiers and tying them back to the same unique person, effectively generating a single unified view of the customer. Now, identity graphs are central to all advertising, marketing, and customer experience activities. It powers real-time personalization for ad targeting, content product recommendations, and also email notifications and alerts. Some of the things you can actually do with identity graphs are things like targeted advertising recommendation, improving the digital consumer experience, understanding your customer's journey. So your customers generate many signals of intent, such as search queries, product page views, ad clicks, purchases, loyalty program enrollments. And identity graphs allows you to analyze end-to-end customer behavior to gain that 360-degree view of your customers, so you can actually better understand purchasing patterns and improve marketing attribution. And also, we need to do all this while maintaining privacy and compliance and security. So managing your customers' personal identifiable information, PII, and non-PII data separately is operationally expensive. And some regulations require combining these sources to support requests for information, RFIs, and also delete requests. And identity graphs allows you to store and manage PII and non-PII data together. So how does an identity graph actually work? Well, identity graphs are typically one part of the larger identity resolution flow. So if we look at the logical flow from a business perspective, we can break it down into several layers. So first, we collect structured and unstructured data from different sources. This could be first-party data that you collect from your own platforms or CRM, or perhaps you also have additional third-party data from data exchanges or data partners. Now, the next layer is about ingestion of this data, including any validation or cleansing of the data that is required. Next, we want to build the actual identity graph. But before we do that, we need to unify identifiers and anonymous users back to known users. Now, you can do this through a process called identity resolution, which is used to connect the dots. So once the unified profiles have been built, they can be stored and used to power customer data platforms and audience platforms through an API layer. Now, if we translate the logical flow into a technical perspective, we can fill each layer with services that achieve the given functionality. The exact services used within each layer can be interchangeable, but we give a few common examples we see. So starting from the leftmost layer again, data collection. Ingestion of data flows into some type of data store like Amazon S3 and combine that with validation and cleansing processes. Now, you could use a mix of AWS Glue, things like Serverless Spark, or Amazon EMR, or even AWS Lambda functions to transform and prepare your data before identity resolution happens. Next is identity resolution, or the process we use to determine which anonymous user is linked to which known users, or which identifiers like phone number or email address are associated to a particular user. Now, there's two main ways of doing this, either probabilistic or deterministic identity resolution. Once identifiers have been stitched together, we can store all these unified profiles in Amazon Neptune, our managed graph database service. And then finally, we can expose our unified profiles to our end services through an API layer. Now, you could use one of our managed services like API Gateway or AppSync backed with Lambda functions to achieve this. Or you could use other compute if you want, like EC2 or containers. So now what we're going to do is we're going to roll into a demo of using identity graphs. In this demo, you can see a customer and the information we know about them. For example, for this customer, customer 24, we know their phone number, we know their email address, the fact that they use a payment card, and their username and device that they use. What we want to know is, are there any customers that share similar attributes which may be the same customer we're looking at? Now, we've run some queries in the background to actually map or to build a map of which attributes are shared across which customers. Now, the output is actually shown here, where we have 3 columns. Now, the first 2 columns are the customer IDs, and the third column displays the attributes actually shared between the 2 customers. Now, as you can see, this could be device, this could be a payment token, phone number, email address, indeed a combination of attributes. So what we're going to do, we're actually going to take a closer look and show and see how different customers are actually connected by payment card. So we've got a map here. So here are our 2 customers, customer 6 and customer 59. And we can see that they're sharing the payment card 191. We can see that they share a number of attributes, in fact, email address and phone numbers. So the data suggests they are actually highly connected, which leads us to believe they potentially may be the same person. Now, identity resolution helps create a single source of truth, i.e. a golden record of your customers. Well, this allows your marketing departments or the marketing teams to know who they are engaging with and to build highly personalized experiences where you can take all you know about them into consideration. It enables your customer-facing employees to see all 360 degrees of your customers, therefore increasing customer satisfaction. You'll also learn more about the neighbouring network of your customers to better understand their influence and how to generate new sales opportunities. So let's now extend our concept of shared attributes and see how we can apply it to a concept known as householding. So we're pretty sure that, let's take a look here. We're pretty sure that we've got some customers who are in fact using the same device. So let's scroll down and see if we can find some here. Fantastic. Let's go to this device here. So what we can see is we can see a number of customers going through the same device. We've got customer 45, customer 76, customer 43, and customer 28 and customer 21. Now, if we look at these customers, they only share a device between them, in fact. So they're actually unlikely to be the same person. However, they may be adults living in a shared household. So we can find many records like these and actually group them together in what's known as a household. So at this point, marketing teams can actually start to ask questions like, who is the customer? Who are we actually targeting? Is it the individual or is it the household? Does a set of adults living together need more than one video streaming subscription, or do they need more than one grocery delivery service? These are the areas which can actually be leveraged, like householding, to save marketing costs rather than marketing to individuals. So this is the end of the demo. Let's head back to the presentation. Fantastic. So to summarize, identity graphs leverage the highly connected nature of graph databases to help identity relationships between real-world entities by modeling data such as email addresses, names, date of births, etc. as objects within their own right, and then creating connections between all the people who actually share the same data. Now, they're used to combine data from billions of interactions between people, websites, and devices to create a unified view of interests to help create targeted audiences for marketing and advertising purposes. So you're interested in identity graphs. Like, what are the next steps? Firstly, come and explore the demo website for yourself. As you've seen, you can build a visualization that shows how data is connected and shared across multiple real-world entities. As we've discovered, there are many different use cases for building identity graphs on Amazon Neptune. Today, we focused on linking customer identifiers and householding. But if you're interested in learning more about the other use cases, as well as reading how our customers are building their own identity graphs on Neptune, please check out the Identity Graphs on AWS section of the Amazon Neptune product page. If you're looking for more hands-on experience with Neptune, why not go ahead and deploy a database cluster and actually try it for yourself? From there, you can use our open source Neptune notebooks to deploy example identity graph data and walk through typical queries that identity graph customers are running on their graphs. And finally, if you're interested in building a similar use case, why not get in touch with the Neptune specialist SA team here at AWS? We've helped support hundreds of customers successfully build their graph workloads on Amazon Neptune. And with that, I'd like to say a big thank you for watching.